Are you interested in what is possible based on physics? Our summary today works with the book titled The Science of Can and Can't, a Physicist's Journey Through the Land of Counterfactuals, from 2021 by Chiara Marletto, published by Penguin. This is a great preparation to our next interview with Chiara Marletto in episode 308, talking about the connection of physics and the future of cities, as part of the Podcaston 2025 global event. Since we're investigating the future of cities, I thought that it would be interesting to see what possibilities are present according to physics. This book introduces constructor theory, a shift in physics from describing what does happen to what can or can't happen.
What is the future for cities? Do you want to learn more about them? Do you want to know how others think about them? Do you want to be part of the conversation? Then this is the right place.
Welcome to today's What is the Future for Cities podcast and its research episode. My name is Fanny, and today we will introduce a research by summarizing it. The episode really is just a short summary of the original investigation, and, in case it is interesting enough, I would encourage everyone to check out the whole documentation. This conversation was produced and generated with Notebook LM as two hosts dissecting the whole research.
The deep dive on Chiara Marletto's The Science of Can and Can't.
It's quite a fascinating read.
Yeah, and prepping for this, let me tell you, my brain's already tied in knots a couple of times.
Yeah, it's a pretty big shift in thinking.
It really is. So the basic idea is she's saying there's this whole other way to think about physics, not just like what happens, the stuff we can observe, but what's actually possible or impossible at a really fundamental level.
It's a very different way of looking at things. Marletto calls it constructor theory.
Constructor theory. Okay, I like it.
And it's really about identifying those kind of universal can't-do lists. Like, no matter how clever you get, these things just aren't going to happen.
So not just I can't dunk a basketball limitations, but like universal no-go zones.
Exactly. We all know perpetual motion machines, they're impossible.
Right.
But traditional physics gives you a description of why. Constructor theory wants to explain those impossibilities.
Okay, so it's like we know the rules of the game, but then constructor theory comes along and says, hold on, let's talk about why those rules exist in the first place.
That's a great way to put it, actually. It's like traditional physics gives you the instructive manual for the car, but it doesn't explain the laws of physics that make cars possible.
And Marletto's trying to uncover those deeper laws.
Yeah, she is, and she's coming at it from a completely different direction. Instead of breaking things down into their tiniest parts and then figuring out how they interact, she's looking at what a system can do as a whole. If you think about a chef, you don't describe them just by the ingredients they have in their kitchen.
You describe them by the dishes they can create, right?
Exactly, and that's the core of the constructor idea. It's about potential.
Okay, so it's not predicting a single outcome. It's about understanding the whole range of what's possible and, importantly, what's absolutely not possible.
Yes, and to get to that, she uses two main principles. They're called counterfactual resilience and universal constructors.
Counterfactual resilience. Oh, those are some big words.
Think of it like this. The laws of physics are like unbreakable rules, okay? And they tell us what transformations are impossible. So you can't create energy from nothing is one of those rules.
Okay.
And this law would be counterfactually resilient because it's true no matter what.
Even if we could rewind the universe.
Exactly. It would still hold, even if you could fly by flapping your arms really hard, which you can't because physics. So it's those absolute no wiggle room impossibilities.
Got it. Okay, so then what about universal constructors? What is that all about?
Imagine a machine that could literally build anything, as long as it's physically possible. It wouldn't be breaking any laws, just carrying out transformations.
So like a 3D printer, but on a crazy level. Like instead of plastic, it could rearrange atoms, like at will.
Yeah, exactly. It's like the ultimate 3D printer. Now, a universal constructor might just be theoretical evolve, but thinking about it helps us figure out what are the limits of what's possible.
What are the rules of the game?
Exactly.
It's like looking at like the Empire State Building and being like, what are the physics that even make that possible?
And then once you understand those laws, then you can maybe start to think about other structures that might be possible, things we haven't even imagined yet.
This is already, my brain's hurting a little bit. We haven't even gotten to the really cool stuff yet, right?
This is just the tip of the iceberg. Yeah, we're going to get to applying this to information, to computation, even to the definition of life itself. It makes really wild.
Hold on. Information. We're talking about bits and bytes and stuff, not just stars and galaxies.
Oh, yeah. Constructor theory has some radical things to say about information. It says, information isn't just some abstract concept. It's a physical property.
Okay, wait. A physical property, like mass or electric charge. How could information be physical?
Think about it this way. A blank DVD and a DVD with a movie on it. They're made of the same stuff, but one has the potential to encode information, to transmit it in a way the other can't.
So it's not the data itself, but the system's ability to embody different states. Is that what you're saying?
Exactly. That blank DVD had more potential information because it can be written to. Information being physical, it has huge implications, especially when we start talking about things like quantum computing.
Those are already mind-blowing enough on their own.
It gets even weirder because quantum computers, they take advantage of the weirdness of quantum mechanics to do things our regular computers can't even dream of. And they do this by essentially tapping into those could-be states, the potential that regular computers just ignore.
So they're not just faster, they're using a whole different level of information.
Exactly. And what's cool is constructor theory might help us figure out the absolute limits of what can even be computed, no matter the technology.
Okay, so even if we had a quantum computer the size of Jupiter, there would still be problems it just couldn't solve.
That's what constructor theory seems to suggest.
Wow. But we were talking about biology before, and you said this has something to say about life. Like, how does constructor theory fit in with that?
One of the most fascinating things about Marletto's work is that she says life can be understood through this lens of constructor theory. It basically sees life as a system that's carrying knowledge.
Hold on, wait. You're saying life is like a knowledge-carrying system? Our DNA isn't just a blueprint, it's a library.
Exactly. Think of it like this. It challenges our typical ideas about evolution. It's not just about random mutations. It's about which of those mutations are even possible given the laws of physics and the environment.
So it's not just a random walkthrough, like all these evolutionary possibilities. It's like a guided tour. You can only go down certain paths.
Exactly. And that has huge implications for how we understand the origins of life and how it evolved. It suggests that life might not be such a fluke. Maybe it's more of a natural consequence of these laws.
So life might be more common in the universe than we think, and potentially far weirder than we can imagine.
That's one of the exciting possibilities.
This is getting pretty deep, man. We're talking about rewriting the rules of biology now, not just physics.
That's what makes this so compelling, though. It's forcing us to rethink some really fundamental things about the universe, information, and even life itself.
Okay, so we've got quantum computing, biology, evolution, any other scientific fields getting this constructor theory makeover.
Oh yeah, definitely. It's even changing how we think about thermodynamics.
Thermodynamics, the study of heat and energy. What does constructor theory have to say about that?
So traditional thermodynamics describes how big systems behave, like gases or engines. But constructor theory goes deeper. It focuses on the tasks that can and can't be performed at a fundamental level.
Like that whole thing about how entropy isn't just about disorder, but about certain tasks being impossible, like unscrambling an egg.
Exactly. And this has some fascinating implications for one of the biggest mysteries in physics, the arrow of time.
Why time only goes in one direction, you mean?
Exactly.
Yeah, I've always wondered about that. Is that just like a human perception thing, or is there something deeper going on?
Constructor theory suggests it could be like baked into reality, that the can'ts of the universe, those things that can't be reversed, they might be what give time its direction.
So instead of the arrow of time being something that emerges from complex systems, it's actually fundamental, like part of the laws of physics themselves.
That's the idea. And it raises some really profound questions about causality, about what time even is, maybe even the origin of the universe itself.
Okay, yeah, I'm starting to see why this theory is causing such a stir. But with all this talk about revolutionizing science, are there any skeptics out there? Are there people who are like, hold on a second, this is all a bit too far out there?
Yeah, you're right to ask that. Any new theory, especially one as bold as this, is going to face some pushback.
What are the main criticisms of constructor theory? Where do people poke holes in it?
A common one is the lack of experimental evidence. It's a very abstract framework.
Okay.
And a lot of people say, show me the data.
You can have the most elegant theory in the world, but if it doesn't match up with reality,
It's not very useful.
yeah.
And Marletto herself acknowledges that. She and her colleagues are working on developing experiments, especially in quantum information and computing, to see if they can find evidence to support these ideas.
Okay, so the jury's still out, but the research is ongoing.
Exactly. And another challenge is integrating constructor theory with existing theories. It can't just exist in isolation. It's got to fit in with what we already know about physics.
Like quantum mechanics, general relativity, all that stuff.
Exactly. You can't just build a new wing on a house without making sure it's structurally sound.
So those are the scientific challenges, but are there any philosophical ones?
Oh, yeah, definitely. A lot of scientists are used to thinking in terms of deterministic laws and predictable outcomes.
Yeah.
Constructor theory asks them to think differently, to shift from what is to what could be.
Like we're so used to seeing the universe as this giant clock ticking away. And now we're saying maybe it's more like a choose-your-own-adventure book where there are all these different possibilities.
That's a great way to put it, yeah. It's a big shift in thinking for a lot of people.
Okay, yeah, that's a big jump.
Well, one of the things that really struck me about Marletto's book is how she blurs the lines between science and philosophy. Traditional physics, it's all about describing the universe as it is.
Right.
Constructor theory is asking, what could the universe be? It's about potential.
Okay.
And that leads to these really deep questions about knowledge and meaning, even purpose.
Like earlier we were talking about free will and how even though we're governed by these laws of physics, there's still room for choice within those laws.
It's like the universe sets the boundaries, but we get to play the game.
Exactly.
And to play that game, you need knowledge. And Marletto has a very specific definition of knowledge. It's not just information. It's information that can be copied, applied, and built upon. So it's not static. It's active.
Interesting. It's not just knowing the ingredients, it's knowing the recipe.
Exactly. You're taking raw information and transforming it into something more, something with potential.
So knowledge itself is a constructor.
That's a great way to think about it, yeah. And this connects really nicely with how science works. Scientists, they're constantly making conjectures, testing them against reality, building on what works. That's how knowledge grows and becomes more resilient. It's not just about what's true now, it's about what could be true if we understand things better.
It's making me think differently about what even counts as knowledge. It's not just the facts I've memorized. It's like my ability to learn to adapt to new situations using what I know.
That's it. That's the heart of it. Knowledge as this active process, not just a collection of data.
Okay, this is pretty mind-blowing, but let's zoom out for a second, get a little cosmic here. If the universe is this tapestry of possibilities, and knowledge is the tool we use to navigate those possibilities, does that imply some kind of meaning or purpose to existence?
Ah, the big question of purpose. Now, constructor theory doesn't give us a definitive answer, but it does offer a pretty interesting perspective. If knowledge is fundamentally tied to the structure of the universe, then maybe the pursuit of knowledge, that drive to understand and create, maybe that's a kind of cosmic imperative.
So we're not just passive observers. We're built to explore and push the boundaries of what's known. Like curiosity is in our DNA.
And by doing that, we're not just uncovering the secrets of the universe, we're actively contributing to its evolution. We're adding to that tapestry of possibility.
In a way, constructor theory is saying that we're not just along for the ride, we're active participants in shaping the universe.
Exactly. Our choices, our actions, our quest for knowledge, they all play a role. It's a pretty empowering thought.
It is, but it's also a little daunting. Constructor theory gives us this incredibly vast perspective where everything is connected, everything is changing, and everything is full of potential.
It's a lot to take in, but that's what makes it so exciting, right?
Absolutely. So where do we go from here? What's the next chapter in this exploration of possibilities?
For scientists, the journey continues. We need to keep testing, refining these ideas, seeing how they hold up under experimental scrutiny,
Right.
seeing how they connect with all the big theories we already have.
Like quantum mechanics, general relativity, all that.
Exactly. But for the rest of us, I think the key is to just embrace this idea of possibility. Remember that the universe isn't this fixed, rigid thing. It's constantly evolving. And we are a part of that evolution. We're creators, we're explorers.
We're all shaping the future, not just for ourselves, but for the universe as a whole.
That's it. And never stop asking what else is possible.
And if you want to explore the ideas further, we highly recommend Chiara Marletto's book, The Science of Can and Can't. It's a challenging read, but it's so worth it. It will make you question everything you thought you knew about reality.
What is the Future for Cities podcast?